That is okay. Okay. So we continue for this chapter. Okay, for chapter 4, which is a core part for the product design. Okay. If you remember in chapter 1 and also chapter 3, we actually is define the product design. Okay. And for this part, actually in the main textbook is you can see in the second part of the books. Okay. So it's focusing on the design of the products. Okay. So which is we want to focus on the product design synthesis. Okay. So and the design of the products, we begins with the assessment of the possible need for a new product or process. Okay. So the concept is to satisfy the need uh, of the consumer. Okay, the need are generated and examined for the technical, economic, okay, as well as feasibility. So we have to consider also the safety, okay, controllability as well as environmentally concern. Okay, so for these molecular products, okay, or the product design, okay, the synthesis and the design of the new chemical products include the molecular products, which is a single type of the molecules or pure products, which is, for example, like a refrigerants, that is a single a type of the molecules or pure products, as well as mixture blended products. Okay, so it's a combination of different molecule in liquid solution or blends. Okay, so we will discuss in the chapter. As well as first part we will focus on the we will represent about the molecule structure. Okay, they have a single type. Okay, as well as mixture blended. And then second part, selecting the feasibility candidate. Okay, molecules and mixture. Okay, so that we can provide the desired properties. Okay, as generated from the product needs function. Okay, and then number three is we will present about the estimating of the properties of molecule and mixture. Okay, and then we will focus on the computer aided frameworks or CAMD. Okay, we're gonna use the software. This one we're gonna do the software for the case study. Okay, there's many software. I think we will focus on the ICAS or what software. Last time we used ICAS. I don't remember that another software. Okay, but the main software is ICAS. Okay, and also some example. Okay, also some project. Okay. So for today actually okay, this is introduction and overview. Actually I have to give this lecture last week, right? Introduction and overview. But we cancel of our class. I have some work to do. Okay. But maybe today we will discuss about the introduction and overview as well as a framework for the computer aided molecular design. I think the design mostly focus on the I think it's not framework. Okay, it's just introduction. Okay, focus on the uh, problem formulation and pre-design phase. Okay, so problem formulation. Okay, so it's just an introduction before you apply on the computer aided molecular mixture and blended design. Okay. Okay, so let's see the overview and the objective. Okay, so this part actually we want to introduce two classes of chemical products. Okay, two classes of the chemical products. Look at here, identical molecules in the products, which is known as the molecule products. Okay, as well as the different molecules are present as a liquid solution or blends. This is what we call as a mixture blended product. Okay, so it's different. Okay, because this one is already blended and this one is a molecule products, the pure one. Okay, generally is a molecule structure. Okay, and from this one, there's a following questions that regarded on the importance of good understanding of the issue related to molecules and mixture design. Okay, what is the important questions? Okay, first, how to represent the structure of molecules. This one you have to know. Okay, before you do the product design, and how to generate chemically feasible candidate molecules and mixture. Okay, and how to estimate the properties of the molecules as mixture, as well as how to formulate and solve that typical molecular and mixture design. Okay, so generally if you use computer aided CAMD, okay, and you need to verify by using experiment. This is what I told you last time. Okay, so actually there are many ways to design the molecular and mixture design. Okay, 101 ways. Okay, but what we are focusing is only consider the framework based of the computer aided methods and software. Okay, this is what we're focusing. Okay, because we can screening the target compound and reduce the number of the molecules. Okay, so the design approach, we identify promising design, okay, alternative based computer aided technique, okay, and then experimentally verified and fine tuned at the later stage. Okay, so employ first quickly and reliably reduce the space within optimal design like to be found. And then second, later stage, okay, this is what I told you, verify experimentally. Once you determine by using computer aided techniques, okay, you have to do the fine tune. Okay, once you reduce maybe the molecules from 1000 to reduce to 50 or tens, so you have to do the experiment to verify. Okay, and then focus experiment perform and identify set of promising alternative. So first step, okay, and then this one second step. Okay, okay, so from all this one, what we expect as a outcomes. Okay, so I hope that you can recognize the characteristic between single molecules as well as liquid mixture. Single molecule is pure. Okay, this pure also we can use for many applications. Okay, or if liquid mixture such as you blend together, you make a makeup or lotions. That one is we blend. Okay, ability to convert the needs function of the product to be properties of single molecules or liquid mixture. Okay, and you have to be familiar with the CAMD and the software because you want to do selection or screening, design, analysis of the products. And then you able to select, design, and analyze product composed of the same molecule throughout the products. Okay. And number five is you able to select, design, and analyze liquid products composed of the mixture of the different molecules. Okay, so if you remember in chapter one, okay, the classification of products, okay, the molecules and mixture product or liquids is actually is belong to B2B type or business to business type. Okay, so typically molecule products, okay, this one, okay, molecular, okay. So if you look at here, that's the molecules, okay, or molecule product is eventually help to manufacture desired the chemical base product. This one, okay. Look at here, this one. This is the molecule, okay, molecular products, okay. This one, okay. And then look at here for the mixture blended products, okay, for the mixture blended products, okay. We can hear the application incorporated in other chemical base. Okay, so in the final product and have incorporated in the final product and have a specified function in the product. This is what we call this mixture blended product. Okay, so there's a pure as well as mixture blended. Okay, if you remember, they have a B2B as well as B2C. Okay. So let's see the type of the molecular products. Okay, actually is varying in the size. If you remember, there is a varying type. There is aromatics, and they have many functional group. Okay, there is a linear. Okay, so the molecule structure also complex. Some complex, some is not complex. So there are three types of molecular products that are very in size and molecular structure complexity. Look at here for A, okay, usually have a process related application or maybe part of the mixture formulated products. For example, you mix with the solvent which is easy to evaporate, like you use for the what is it? Lotion. Okay, when you apply in your on your skins, okay, the solvent is easily to evaporate at the room temperature, but at 25 degree at 25 degrees C, at 25 degrees C, the solvent in the liquid form. Okay. Okay, and the B, C usually employed as the main active ingredient of the chemical base. Okay, and the molecular structure of the type C may be manipulated to obtain specific product function. Okay, and this one is the mixture blend design. Okay, different chemicals are blended to obtain a liquid solution product in with desired properties. Okay, so this is this type of type of the molecular product you have to remember. Okay. So and D is classified as the mixture blend and product. Okay, so let's see the example of the application this molecular products. Okay, generally for the solvent. Okay, this is a good example for both molecular and mixture products. Okay, so we can employ maybe in the process industry. Okay, as well as in the chemical based products. Okay. For example, solvent-based operations, okay, we can use in the separation, okay, distillation, cleaning operation, and also organic synthesis, okay. And then in each operations, we the solvent have a different function, okay. So the feasibility of the chemical product manufactured through a solvent depend on the successful selection design of the solvent, okay. So that one is this one is the example, a good example for the unit operation. But how about for the product design? Okay, if you look at here that the for the product design, okay, it's quite different with the unit operations or for the process. Okay, solvent usually we incorporated, okay, in the formulated products. For example, cosmetic products. Okay, so such as lotion. Okay, the function to deliver active ingredient to skin and then leave by evaporation. This is what I told you, which is in a liquid solution in a liquid solution at a 25 or 30 degrees C. But suddenly when you apply on your skin, it's going to be evaporate. Okay, and the performance actually is depend on the function of the selected solvent or molecule of the mixture. Okay, so this is the example of the molecule and the blended mixture blended products. Okay. Okay, so any question about this example about the mixture blended as well as the molecular products? Okay, so if you have no questions, okay, maybe some of you already leave this uh, I'm not sure, leave this class. Okay, so let's see single molecular products. Okay, if you look at here, this is the example, which is a single molecule product, also known as a uh, nearly pure or pure, because we use usually a single molecule products. Okay, for example, like refrigerants. Okay, the rule is to absorb and release energy. Okay, in different state. Okay, if refrigerants, they use I don't remember that one. Okay, R134 I think. Okay, so that is the almost pure of the compound. Okay, so it can change in the temperature and pressure. Okay, in the refrigerant or heat pump cycle. Another example is an emulsifier as well as active ingredients. So emulsifier is for the surfactant and create and emulsions. Okay, active ingredients is main function for the chemical base such as a drug, caustic. Okay, but the important issue is need to perform specific function, okay, related to their properties as pure chemicals. Okay, this is quite different with the mixture. Okay, so the properties, if you look at here, that for the mechanical molecular design problems, okay, need the specific function related to the properties of the pure chemicals. Okay, so actually is differ based on their need function. For example, pure for the refrigerants, they have to use different chemical emulsifier, different chemicals. Okay. So a typical molecular design problem we can define as a given a set of building blocks. Building block is the chemical compound, okay, and a specified set of the target properties determine the molecule that match these properties. This is what we define as a molecular design problem. Okay, so it is given a set of building blocks. Okay, set the target of properties, and then you have to match with these properties. Okay. Okay. So for the mixture blend design problems, okay, when the need function of the products cannot be matched with the properties of the single molecules, okay, so mixture blends are different molecules are considered. Okay, so just like molecular products, for example, in the performed for the operations, example blend of the solvent, lubricant as well as a process fluids. Okay, so we can perform for the specific operation, okay, in the process industry, and as well as we can perform for the specific function in the different type of product. This is for examples for the perform for the function of the specific functions. This is example like additive to fuel or solvent blends in the paints. If you remember, last time we do the tutorial about the CMC. Okay, so we can use for the additive for the paint, okay, or coating for the and constructions, as well as additive for the foods. Okay, that is for CMC, as well as what else? Ethyl cellulose, I think. I don't remember that one. Also can use as a food additive. Okay, so there's many function of the compounds. Okay, so just like molecular products, the application of the mixture products, okay, we need to define their needs functions, okay, and we need to define the set of properties the blend, okay, and must provide to perform its functions. Okay, so generally the chemical in the mixture design problem could be first generated through the molecular product design step. Okay, many types of the mixture blend products. Okay, but for this part we only cover mixture blend that are stable liquid solution are cover. Okay, so for the mixture blend design products we can define as a given set of chemicals, okay, and a specified set of properties. Constraints determine the optimal mixture or blends. Okay, this one is for the mixture blend design problem. Okay, okay. So let's see what is the need functions. Okay, need function based on the previous discussions or previous slide. Okay, one of the important issue is related to molecule mixture design. Okay, which is a set of the properties of the single molecules. Product must at least be liquid at the condition of application. So you have to remember this one. Okay, must be liquid. Okay, you apply must be liquid. Okay, and must dissolve at assigned solute. So you have to find the suitable molecule or compound which is can dissolve. If non-dissolve is meaningless. Okay, for example, organics, you have to find the compound which is organic. Okay, so that is the next function. Okay, so what should be in the required property of the solvent? Okay, this is what you need. Okay, so another important things that we need to consider is a properties value. Okay, which is maybe measure from the database. Okay, of measured data or calculated through the use of appropriate property models. Okay, how to obtain, so we can obtain experimentally. Okay, as I told you, this one retrieved from the database of the measure data. Okay, calculated through the appropriate property models or by using computer aided techniques. Okay, this one. Okay, So, but the other related issue is the sometimes it involve the structure of molecules or of the structure of the molecules for the molecule products and the composition of the molecules in the mixture blend products. Okay. So this one is for the computer aided techniques must include a database of the major properties value. Okay, computed by the library of the properties. This one you can obtain from the computer. Okay. So let's see the molecule structure. Okay, this is property data or estimated insufficient. Okay, so what you have to do, you have to generate the molecule structure. If you use a software like ICAS, you can generate the molecule structure. You have to insert the data. So, it's almost similar like you use ICIS or Aspen Plus. Some data is not available, so you have to generate. Okay, and employing appropriate building blocks can be combined to perform molecule through a set rules and ensure their molecular stability. Okay, so some properties models require structural data. Okay, the advantage is the building blocks is to predict molecular properties. Okay, so the generated molecules must be checked so that it can match with the target properties value. Okay, so you have to remember this one. Okay, once your data is not sufficient, you can generate by yourself, but you have to check your data or verify. Okay, generally, if you want to verify, you can use the experiment. Okay, this one is for the molecular structure. How about the mixture blended products? Okay, so for the mixture blended products, specific molecule actually you can confirm. Okay, you can confirm to certify the liquid phase stability. Okay, so at the specific temperature. Okay, so for the appropriate models, you can estimate the needed properties value, and also you have to test the match with the target properties. This one is almost similar like a molecular structure. Okay. Okay, so the essential gradients for the molecular designs. Okay, first is to present stable molecular structure, method to generate chemical facility molecules, as well as a method to estimate the required properties. Okay, for the mixture designs, the method is generate stable mixture blends, as well as method to estimate the needed properties. This is the comparison between the molecular as well as mixture design. So you have to remember this one. Okay. Okay. So, any question about this one?
No, it seems like normal theory, doctor, no
Yes, it's
question.
normal theory because it's an introduction. Before you actually the main part you have to do use a software to solve the some case study later, such as solvent to use for refrigerants, solvent for the what else? For the lotion, you have to do that
Okay,
one. Okay, later you have to do
okay.
by using other
The
software.
software, understood.
Okay, yes. Okay, this
Okay.
is a core part actually, but today is just general information. Okay, but you have to know the difference between molecular product as well as mixture. Okay,
Understood. Okay,
okay.
doctor. Right.
Okay, so if you look at here that due to the number of generated chemically feasible molecules of mixture can be very large. Okay, you have to remember if there's a many molecules, okay, we need a systematic framework. That's why we use a software to generate the molecule structure, test their properties, okay, and then you verify by using experiment. This one is the thing that you have to do later. Okay, okay. So, what you're gonna cover later, actually, frameworks for the computer aided molecular design, which is next part, and then Mr. Blend Design, CAMD, okay, CAMBD. That one is for blend, okay. The subsection you're gonna cover is the molecular structure representation, okay, generation of the molecule of Mr. Design. This is the framework, okay. Property prediction, okay, problem formation, problem solution, as well as solution approach. Okay. So, and as well as some case study, okay, such as Telemate gasoline blend. If you remember, there's a blend of the gasoline, the additive, or gasoline with the biofuels. Okay, solvent substitution, refrigerant design, active ingredient design. Okay, this is the case study that you're gonna cover later. Okay, so actually the case study will be prepared by Dr. Azizo. So I just wait from him. Okay, and then we can discuss this case study together. Okay. Okay, so we have a activity, okay, about 25 minutes. Okay, you have to do in your group. Okay, let me paste the link for the Padlet. Okay, I think it's already placed here. Where's the Padlet? Okay, there's some activity. Okay, given the list of needs function application of the molecular products, single type of molecules. Okay, this is a single type. You have to remember molecular products. They have three types A, B, C. If you remember. Okay, translate it into measurable properties. Okay, provide three example molecules. Okay, only three example which can satisfy the needs function and provide the value of the properties. Post the answer in the Padlet. Okay, here are the list of the general case study application. Okay, you have to base on this one. Okay, solvent must be liquid form at the extraction process of 25 degrees C. Okay, and then to avoid harmful condition, especially when the process is near to ignition source, the solvent used in the process must be non-flammable. Okay, perfume is a mixture of fragrance oil in the solvent. When the perfume is sprayed, the solvent need to be evaporated right away, leaving the fragrant compound in the perfumes. Okay, so please do this one. Okay, what is the molecules, type of the molecules for the this solvent? Okay, for the perfumes. Okay, it's a mixture of the fragrance oil and solvent. Okay, and then you have to paste in the Padlet.
Okay, doctor.
Okay, so we will discuss. Okay, so about 25 minutes ago, until Doctor, I can see. Okay, okay, wait. Can you see the question?
Now we can see, doctor.
Okay, sorry, because I want to okay take the so needs function is the need function. So please suggest not different than perfume, okay? Not only perfume, okay? That one is just a general case study application. The example. Okay, given a list of need function. For example, it could be evaporate. Okay. For example, this one solvent must be in liquid form at the extraction process of 25 degrees C. That one is a needs function. Okay. The solvent is single time. Okay. Okay. Provide the example of molecules. For example, you use acetone or maybe methanol. Okay. Or maybe ethanol. Okay. So you have to consider also the what is it? Uh, needs function as well as the properties values. Okay. And not properties values, just the needs function. Okay. Which is you have to consider the safety, okay, environmental uh, consideration. Okay. Not only perfumes. Okay, maybe lotion. What else? Toothpaste. Okay. What else?
Hand sanitizer.
Yes, sanitizer also. Sanitizer also possible. What is the molecule inside there? Okay, I think it's almost similar. Once you apply the sanitizer, the solvent must be liquid form, right? And then it's gonna be evaporate at the room temperature. That is the needs function. Yeah, that's good example for sanitizer. Chemicals in perfume, yes, chemical in Fahad. chemicals in perfume. Okay, you have 10 minutes. Deodorant. Okay, let me share. Okay, let me share the. Okay, let me share this one. Share. Oh, should we share? Let me share. Ashraf Arifin, Group 7. Oh, I think we have 14 group, right? I hope all the group can. Chemical and perfumes. Is that similar? Fahad, what you say? Okay. I hope
Yes,
we
doctor.
can. Is it there's a same ethanol or isopropyl alcohol or different group? Can you put another one is which group? This one chemical and perfume also. Can you put the name group name? Which group? Group 4. Okay. Fahad, isopropyl alcohol evaporate quickly when spray or left open. Okay. Evaporated faster than water in room temperature. Yes. For formaldehyde, limonene, limonene, methylene chloride. I don't. Is it for good order? Is it we use formaldehyde? It seems like formaldehyde is
Uh,
quite dangerous.
Doctor, actually, it's like I was reading. It's like they use a mixture of chemicals, like different percentage. I was trying to find the proper
The proper
percentage and
amount.
everything.
Yeah, the
But
percentage. Okay,
right,
okay, okay,
just
okay.
trying to find that. I still
Yes,
couldn't
yes.
find it.
Later we will. They have a case study. How can we replace the what is it the toxic or chemical with the non-toxic chemicals such as dichloroethane, dichloromethanes. Okay. So benzene, okay. We will
Okay,
design that one. Okay. But yeah, I think since the percentage is very low.
very low.
Group one ethanol used to extract fragrance, yes. Benzyl acetate possess sweet and pleasant aroma. Okay. Hexane raw material is submerged hexane in hexane so that desired aroma can be dissolved. Hexane, is it they're using hexane? Can you confirm this one? Group one? Hexane is quite dangerous also, but I'm not sure in term of the percentage. I think it's very low percentage. Okay. Group 7, deodorant, mixture of ethanol, butane, isobutane, yeah. Okay. To evaporate quickly, PPG. Okay. Propylene glycol, absorb moisture vigorously. Okay, good. Group 10, hand sanitizer, yeah. Alcohol-based sanitizer. Generally, we use the propyl alcohol, isopropyl alcohol. Okay, but I think 70% must be 70%. If rubbed through thoroughly to finger and has service in for the period of 30 seconds. Yes. So generally, if you want to use a hand sanitizer, make sure you use uh what is it? It can spread with all your wrist as well as your hands. Okay, for about 30 minutes, 30 seconds. Okay, 20 to 30 seconds. It's suggested around 20 seconds. Okay, then use only a little bit. Okay, followed by a complete air drying can effectively reduce a population of bacteria, okay, fungi, and also some virus, alcohol. Yeah, 95%. Is it? Oh, until 95%. It's possible, 95%. It's quite a lot, 95%. Okay, any more groups? They have a 5 minutes. We have a 5 minutes. Okay, that's good. How about other groups? We can share here. All you use a solvent can evaporate. How about application like a toothpaste, maybe something like a different, little bit different. Mostly is evaporated. Oh, what else? The products. Okay, shampoo. That is also the formulated product. Nail polish remover. Yes, that is good. A good example. Nail polish remover instead of liquid. What is the compound, Michelle? Thinner, yes, thinner. That's good. Toluene and methyl ethyl ketones act as solvent and evaporate fast. Okay. Nail polish remover contains a mixture of liquid like acetone. Okay. So for the needs function, actually from the qualitative, we can measure quantitatively. Okay, you have to remember like you can evaporate at the room temperature. That is a quantitative. Okay. Yes. Okay. So I think that's all. Anyone else before we move to second part? Okay, maybe today we will just some introduction about the framework for the computer-aided molecular design. Okay. As in a polish remover. Stone FM. Okay, so we can have a break for 5 minutes. Okay. For
Hey, doctor.
okay, 5 minutes. So 12 o'clock we continue. For those who want to post in the Padlet, you can post. Okay, everybody can see your answer. resume. Okay. Okay. Oh, I continue in this one. Okay. Sorry. Okay. Since it's pause the recording. So just remember this one, 5 hierarchical step. Okay. And then this is the example. Okay, I already explained just now. Okay, please remember that. So, and then the problem formulation. Design process start with the basic need. You need the ultimate objective and goals. Okay, it actually is going to affect your later phases. Okay, the goal should describe the function of desired chemical product, environment and equipment. Okay, should be performed as well as the capability are desirable and undesirable. Okay, for example, in case of the design of the solvent, right? So it must be dissolved in specified solutes. Okay, must be selective. Okay, not cause negative impact on the environment, humans. Okay, and should be easy to recover. Okay, this one you have to remember because we want to reduce the cost, so it should be recover. Okay, so let's see the example, the few example of the problem formations by using a CAMD. Okay, it can be different type actually. Okay, this is a few example. For examples, phenols. Okay, removing of phenols from the wastewater stream. Okay, by liquid extraction. Okay, the solvent should pose a low health risk for the user, environmental friendly, and could be single molecule or a mixture. So this is a good example actually. Okay, well defined problem. Okay, because the problem we want to remove phenols. Okay, almost all necessary details are given. Okay, properties needs. Okay, solubility. Okay, liquid immiscibility we can identify, as well as goals of values. Okay, need to find the best solvent. Okay, what is solvent to remove phenols? Okay, for example, something that organic, it can solubilize in the phenols, and we remove that solvent and then we can recover phenol. Okay. Okay, so let's see the another examples, which is for as benzene. Actually this one is a quite well defined problem. Okay, look at here, the goals value given. Okay, and the property values of the benzene are already known. Okay, we want to identify the molecule with the same pure component properties of benzene. Okay, for example, if you want to do the extraction, as especially for me, like last time, when I did my synthesis or the isolation of the extractive compound like a wax. Okay, we use a benzene or some aromatic compounds, but we need to replace the solvent. Okay, which is more not harm to humans or to me, as well as to the environment. So we use a solvent almost similar properties like a benzene. Okay, the normal boiling points, it can evaporate at 60 degrees C. Okay, a normal melting point. Okay, of tunnel water. So I choose the the mixture of isotone as well as the water. Okay, so you can perform the extraction effectively to the extractive. So you can extract the extractive like a wax, okay, proteins from the wood sample actually. Okay. So because last time in Kyoto University, the benzene for the extraction is already banned to for using it. Okay, for the extraction. Okay. Okay. So another examples is a not well defined problem. Okay, if you look at here is a solvent used for the washing of the equipment. Okay, find the solvent to be used for washing of an equipment which is environmental friendly and cheap. If you look at here, what is it, right? What is the information is missing? What should be dissolved actually? So it's not well defined the problem. Definition of chips depend on the process involved as well as the current solution used, right? So it's not a well defined the problem. Okay. Okay, another example which is not very well defined problems. Okay, solvent use. This one is not solvent use for the washing of equipment. Actually, is for the additive for the tapes. Okay, okay. Need more information. Actually, this is not well defined. Okay. Which properties are we looking for, and what are their goals value? Okay. So this is another example. Another example, activity. Okay. Very well defined. Okay, but difficult to solve. Okay, because the problem, the potential search space. If you look at here that we want to the envision everything again Alzheimer's disease. Okay, so we can search the among the isomers of X. Okay, well-defined problem, even though number of possible isomer may be large, but we can reduce the number of isomer by using the software. Okay, and then we can perform or verify by using the experiment. Okay, isotrope. Okay, but this one is not a typical product design problem. Okay, we can use AMD. Okay, and we can select the molecule types. Okay, such as the cyclic hydrocarbons. Okay, if you know isotopes, we need a solvent to separate two liquid, right? Because it's miscible together. Okay, if you learn in the thermodynamics, the alpha is equal to 1. Okay, so alpha is in the gas, as the composition in the gas and liquid is similar, vapor and liquid is similar. Okay, so as what I want to summarize is for the problem formation and pre-design phase example, highlight for a knowledge based system. Okay, you need to identify the needed properties. Okay, then their goals value need to be specified and the methods. Okay, so that we can obtain the necessary properties value needed to be selected. Okay, and then qualitative problem must be transformed to the quantitative problem specifications. Okay, so what we need is the needs, goal, and qualitative. We need to translate or convert into the quantitative. Okay, properties as well as constraint. Okay, so method and constraint selections. Okay, we and the objective will transform qualitative to the quantitative specifications. Okay, by using CMD problem. Okay, so the quantitative problem specification consists of the identify need properties. Okay, goal value. So you have to determine. Okay, and then as well as the method for obtaining properties values and also building blocks. Okay, so this is a method and constraint selection. Any question about this one before we do the activity for about 15 minutes? Okay, so can you do this problem formulations? Given a list of the product to be designed, a right problem formulation we are considered well defined. Okay, write in paper or you can write in the Padlet. Okay, list of the product design is hand sanitizer, air freshener, as well as hair creams. Can you formulate the problems, okay, which are considered well defined? So this is the examples, the problems. And this is the good example, the problem formulation. Should describe the function of the hand sanitizer, environmental equipment, capabilities. Okay, the problems formulation and pre-design phase. This one is the example. Can you write down based on these three example given and post in the Padlet? I give you about 10 minutes before we stop. Using the same Padlet. And you have to write activity 2 and your group name. Okay, let's write down. Activity 2. Okay, Tivia. You can discuss with your friend. Hand sanitizer, air freshener, hair cream. What is the problem formulation?
Doctor, do we need to
Yes.
give problem statements for all of them or just any one of them?
Just one. Just one. Not all. You choose only one.
Okay, doctor.
Okay. Write down the problem statement and pre-design phase. Okay. So you have to consider this one. This problem formulation. This one. Okay. Function, environment, capabilities. Okay. This one is the problem formulation. So for example, this one. The well-defined problem is no need. Okay, this one no need. Okay, this one. This one is solvent. This one. Problem formulation. Activity two. Okay. Okay. This one need and goals, and then the quantitative constraint. Okay, need and goals, quantitative is okay. This is the summary. You need needs and goals as a qualitative, and you have to translate or convert to quantitative. Okay. What is your main objective? Main objective, for example, this one. This is the main objective. So, objective is to, this one is good, I think, easy to understand. The objective is to find the suitable solvent for removing of the phenol from the wastewater. Okay, right. This is the main objective.
Doctor,
Yes.
do we need to give a solution to the problem statement?
What do you mean by solution?
For example, like let's say the problem is a molecule, then do you have to give an example of a molecule for the problem?
Oh,
Or is it just the problem statement?
I think it's just problem statement. But it's okay if you want to put. Okay.
Okay.
Then that means you understand.
Okay, thank you.
Okay. Actually, it's just a formulation.
All right.
Okay, someone or an air freshener find a stable molecule that give off a strong and nice smell that will last long. Okay, so yes, that is the main objective. How do you group 10? How do you convert to the properties or constraints? Okay,
Sorry, doctor, how to convert?
to quantitative
Okay.
because you have a goals. Okay, and the properties and the constraints. What is it? Function, capabilities. Air freshener find a stable molecule with a strong the target is to find stable molecules, right? Okay, and then the molecule must be okay. Maybe yes, the molecule must be smell. Okay, give strong. Okay, what else? And sanitizer. I think everybody can see from the padlet, right? I don't have to share from the air freshener design a solvent for it should also not be damaged. Okay. Okay. Fine. Okay. Okay. Good. I think everybody can understand all the problem and how to find how to design the problem combination. Okay. Okay, because it's important to before we move to the next part. Okay. I think we're not gonna cover this one today, molecular structure representation. Okay. So do you have any question about the introduction and overview for today? It's just the general information. I think you also can read from the textbook, but you as a summary you can refer to the slide that I provided in the e-learnings. Okay. Any questions before we stop? Okay.
Sir, I have a question.
Yes.
How do we convert the problem design to from qualitative to quantitative?
Qualitative is your goal. Okay. Quantitative is like this one. It can evaporate at 25 degrees C, right? That is the properties. That one is the quantitative. Okay. Should can be recovered. That one is quantitative. Okay, not cause negative impact. That one is quantitative. But for the qualitative is something like the goals. You want to find solvent that could replace the benzene. That is the qualitative. Needs function. Okay, is it clear? Clear tak?
And
Huh? Okay. Boleh lah. Boleh faham kan?
boleh.
Ah. Okay, anyone else? Properties such as what is it? The boiling point should be evaporate at 60 degrees C, something like that. If you want to do like this, properties. That is well defined, or we call this quantity. This one such as normal boiling point. Okay. Solubility parameter, like a benzene. Okay, that is a quantitative. But the objective, we want to identify the molecule at the same pure component properties as benzene, right? Okay, if you have no question, we stop our class today. Okay, so all the answer in the Padlet, you can refer to the Padlet. Okay, I think if for the test, maybe question something like this, maybe I'm not sure. Okay, with in general, yes, it's something like that. I think chapter 1, chapter 2, and some part, chapter 1, chapter 3, as well as some of the chapter 4, the question is going to be like this. Okay, what is B2B, what is B2C? Something like that. It's just a general information. Okay, if you have no questions, we stop our class and
Doctor,
yeah,
can show the attendance code again.
attendance. Okay,
All right, doctor, the attendance.
okay, I will do the attendance.
Doctor.
Okay, we end our class.
So, doctor, for the test, will there be any guidelines or anything?
I'm not sure. I have to ask the coordinator.
Right.
The guideline, I've still not received any guideline. I think but just online, and you have to submit via e-learning.
Like before
Yes.
last semester.
Yeah, just like a last time. Okay, maybe something like that. Okay, any more? Okay, thank you very much. I'm
Thank you,
gonna
Doctor.
Thank you, doctor.
stop the recording.